So, given 3 points, in the case of this example, 13, -1, -9, 3, and -3, -9, prove that these points are that of a right triangle. So we have 3 points. If I were to plot those points on the xy plane and connect them, I would form a triangle. Is that triangle a right triangle? That's what we want to prove algebraically. So one way to go about this is to not eyeball it, but actually use algebra, is I need to find the distance of all 3 of my sides. So tell me, how many times am I going to have to use the distance formula for this problem? 3 times, right? I need to find the distance with my hypotenuse, the distance between my longest angle, or second longest, and the distance of my shortest side. Same angle on that side. Once you have the distance, then you can plug that into the Pythagorean Theorem to check if left equals right. So let's see. Here's my 3 points. I need to find the distance of each of those sides. So I have d equals square root of 180, d equals square root of 500, and d equals square root of 320. Which of these do you think is the hypotenuse?
How am I supposed to know? The 500.
Very good. How did you come to that conclusion?
Because it's the biggest one.
Yeah, we know the hypotenuse is the largest side, right? So this will be my C that I'm going to plug in. The rest of these we can just call A and B. They're my other sides. But the main important one is you want to find out what is your longest side. Because when I plug that into the Pythagorean Theorem, I see it's all by its lonesome. So we have a squared plus b squared equals c squared. And plugging in my sides here, doing the math, I get 500 equals 500, which means it is a right triangle. So yes.
Wow. Math.
That's, yes. Wow, math.
Wow.
So a lot of work, but this is what we're going to do to prove that 3 points are that of a right triangle.
So again, you can put it in a calculator and just...
How so?
Well, you can put in the distance formula.
Distance formula? Yes.
That formula,
Yes.
and just do it 3 times. And...
Could be, yeah. Just do it 3 times. All right. So let's take this example. Yes, this is what we're doing today. 6, 1, 0, 4, and -1, -7. Again, I got to calculate the distance 3 times. So let me start with 6, 1, and 0, 4. What is the distance between those 2 points? So d equals the square root of the difference between my x values. So I'm going to call this 1 and this 2. So 0 minus 6 squared plus the difference of my y values. So 4 minus 1 squared. There's your distance. So let's see, that's the square root of -6 squared plus 3 squared, which is the square root of 36 plus 9, which gives me the square root of 45. So I have one distance of square root of 45. Go ahead and just keep it like that. No point in simplifying. Next, let me find my distance between 0, 4 and -1, 7. I'm going to call this one and this 2. So d equals square root of my x difference, so -1 minus 0 squared, plus my y difference, -7 minus 4 squared. That's going to give me the square roots of -1 squared plus -11 squared. Oops. Not sure what's going on there. That's the square root of 1 plus 121, and I get a square root of 122. Again, just keep it like the fraction of the radical. So there's 2 sides. One more. I need to find the distance between 6, 1 and -1, -7. Again, I'm going to call that 1 and that 2. So d equals square root of my x difference, so -1 minus 6 squared, plus my y difference, -7 minus 1 squared, and simplify. So that's the square root of -7 squared plus negative 8.
We keep the 1 and negative? I thought we had to change it.
What's that?
We keep the 1 and negative? Or I thought we had to change it since we already had negative.
Negative 1 minus 6.
For the other one.
And that is negative 7 minus 1.
Oh, okay, okay.
Yeah, okay, we're good so far. Which gives me the square root of 49 plus 64, which simplifies to the square root of 113.
I guess.
So tell me, now that we have all three of our sides, we need to plug that into the Pythagorean theorem. A squared plus b squared equals c squared. And which one of these is going to be my c?
The biggest one.
Biggest one, which is?
122.
Yep, square root of 122.
Let's go.
Wow, you're a genius, David.
Square root of 45.
It doesn't matter.
Squared.
The A or B doesn't matter, right?
The a or b doesn't matter,
Yeah.
but the c does matter. So again, that square takes away the square root, which is why we didn't bother with it here. It's going to go away anyway. So 45 plus 113 equals 122, which gives me 158 equals 122. Are those two equal? So this is not a right triangle.
Not a right triangle. Dang.
All that for a
So
no.
I got a question.
Bro?
Yes.
So why don't we just plug it in the diagram?
What diagram?
6104, and it doesn't look like a right triangle. It's not a right triangle.
Does this look like a right triangle?
Yes, sir.
Does this look like a right
No,
triangle?
no, sir.
It doesn't, right? It looks like an obtuse a little bit right
Yeah.
here.
So
So guess what? We did the algebra and it was.
Dang.
You can't eyeball it.
Alright, my fault.
Wait,
Your eyes aren't exact, but your math is. Well, hopefully.
let me just,
So go ahead, give this a try. I'll give you about 5 minutes while I'll take attendance. Let me pick these two first. So using my distance formula, I have the difference of my x, so 10 minus a negative 1 squared, plus difference of y, negative 4 minus 7 squared. This is where that student messed up. Two negatives makes a positive, right? Make sure you make that change, otherwise, well, the whole problem's going to be wrong, unfortunately. That gives me 11 squared plus negative 11 squared, which gives me the square root of 121 plus 121, which is the square root of 242. Everybody get square root of 242 for one side? Okay, so far so good. Let's look at another side. So 10 negative 4 and 12 2. D equals square root of x difference, so 12 minus 10 squared plus my y difference, negative 2 minus a negative 4 squared. Again, make sure you change that to a plus. I get square root of 2 squared plus 2 squared, which is square root of 4 plus 4. How about square root of 8? Did we get that as our shortest side?
Yeah.
Okay. And last but not least, let me look at these 2 points. So D equals square root of that x difference, so 12 minus a negative 1 squared plus my y difference, negative 2 minus 7 squared. Square root of plus plus, that is 13 squared, plus 7, 8, 9, negative 9 squared, which is the square root of, what's 13 squared?
169.
169, plus 81, which is the square root of, what? 250?
do we keep, or does it change it? Oh, never mind.
Everybody get the square root of 250?
No, sir.
Okay. So, now we're going to use the Pythagorean theorem. So a squared plus b squared equals c squared. Which of these values is my c, my hypotenuse?
250.
Very good. Square root of 250 is my c. So plug in the other ones. The Square cancels with the root, so I just get 242 plus 8 equals 250. Doing the math, I get 250 equals 250, which means,
Right triangle.
yes, it is a right triangle.